Greetings. Welcome to Sigma Labs webinar. It is now my pleasure to introduce your host, Mark Ruport, Executive Chairman. Thank you, Mr. Ruport. You may begin.
Thank you very much for the introduction, and good evening, everyone. My name is Mark Ruport, and I'm Executive Chairman of Sigma Labs. And it goes without saying, these are unconventional times. As a matter of fact, this is an unconventional time at 8 p.m. Eastern Time to be giving an investor presentation, especially from my home. So I'm going to give an unconventional talk. As the saying goes, it's 5 o'clock somewhere, and in this case, it's 5 o'clock almost everywhere, so I hope you have a cocktail on hand and you can sit back for the next 10 or 12 minutes and let me tell you our story. I'm sure you're all familiar with this slide, and even though we're a public company that's been in existence for a while, I'd like you to step back and view the company through a new lens. Think of us as an 18-month or 2-year-old startup that you know nothing about, except that we are a software company making waves in the additive manufacturing or 3D printing industry. For those of you that are unfamiliar, wrong slide here. There we go. For those of you that are unfamiliar with additive manufacturing or 3D printing, I'll provide a very brief 50,000-foot overview of the benefits. If you find our story compelling, you can do some research on the industry and the history and the potential of additive manufacturing. It's quite interesting, and as most things appear to be overnight successes, 3D printing goes back well over 30 years to a small lab at MIT. For the last 18 to 24 months of that 30-odd years, our CTO, who spent most of his career at Intel, and a remarkable group of engineers from many disciplines have been working in what I call radical collaboration with our customers and partners to commercialize our technology and bring it to market. Our engineers are an eclectic group consisting of electrical, hardware, software engineers, human interface experts, machine learning programmers, etc. Our senior engineer, and I say that in all due respect, is almost 80 years old. He's one of the longest continuous working programmers in the world. Graduating from Princeton with a degree in electrical engineering, he got his first programming job in 1960, and he's worked for supercomputer companies such as Thinking Machines, research institutions such as Los Alamos Labs, and other technology companies before joining Sigma. At the other end of that spectrum is a young woman who came to the United States from China to get her graduate degree in machine learning and spoke little English a few years ago. And in between the two is a remarkable group of individuals. So what have they developed and how is it different and why should you care? They've built a patented, in-process, real-time thermal monitoring quality assurance system for 3D metal printing. And I know that's a mouthful. But our technology monitors the thermal plume as the lasers hit the metal powder and can detect and classify defects and anomalies during the printing process, examining each layer as it is added to the one before. Before I dive too much further into how remarkable that is and why you should care, I'd like to talk a little bit about how COVID-19 is affecting our business. At the macro level, many large manufacturing companies are rethinking their supply chains. A crisis like COVID exposes how complex and rigid supply chains have become over the years in the never-ending quest of companies to lower costs to gain a couple extra points of margin. Given this complexity and lack of flexibility, we can easily find ourselves in a position where we can't get the necessary products or components to where they're needed. Sound familiar? Well, one way to mitigate that risk is to accelerate the use of 3D printing and move the manufacturing process closer to where the part is needed. Just like Amazon has located distribution centers closer to the consumer in order to optimize delivery. We were recently told by one of our customers who's working from home for obvious reasons, that he's using our product more than ever. He can manage the build process of a critical part from his home. In a sense, our product became his eyes on the manufacturing floor. He could track a build real time and stop the system if it detected a defect that was outside of tolerance for that particular part. Now, we know Amazon disrupted retailing. They raised our expectations and fed our need for instant gratification. It wasn't good enough to get what you wanted in 2 days. It had to be the next day, then the same day. Next, we'll want Amazon to know what we're thinking and deliver it without our asking. Wait, according to my wife, they already do that. Imagine a future of 3D printer factories strategically located across the United States, being managed remotely as they build customized mission-critical parts on demand with only an hour's notice. Our ability as a country to respond to any disruption or unplanned event would be dramatically better than it is today. Additive manufacturing and 3D printing is capable of delivering on that vision if it can consistently deliver quality parts at a reasonable cost. Let me repeat that. If it can consistently deliver quality parts at a reasonable cost. Well, that's our mission, to help that vision become reality by becoming the de facto standard for quality assurance of 3D metal printing. Today, believe it or not, there are no standards in place, and every 3D printer manufacturer has their own solution, which many users have turned off because it provides no actionable information. Now, that's analogous to having various computers in a company with no standard for security or compliance, or even worse, having security turned off. It's unacceptable to the end users, the manufacturers, and the industry as a whole. Today, Sigma's technology is the only known technology that provides real-time, actionable information and works across the majority of 3D metal printers, single, dual, and quad laser in use today. And it's a significant market opportunity for us. Based on the number of 3D printers being forecasted to be manufactured between now and 2027, our addressable market is approximately $2 billion. For every 5% of that market, it represents $100 million of revenue to Sigma. The primary users of 3D metal printing today come from these industries. They require lighter, stronger, and more customized parts. Today, many manufacturers CT scan every part that's produced in order to ensure quality. Obviously, it's not economically feasible to continue to rely on that process as the number of parts being produced grows exponentially. So what's driving the acceptance and growth of 3D metal printing? Well, there are several factors. The advances in raw material, or the metal powders that are being created that create stronger components. There are roughly twice as many manufacturers in the market today than a few years ago. And as you know, competition drives innovation. We're seeing the next generation dual and quad laser printers and more sophisticated software for the design of parts and for managing end-to-end the digital thread or the process of producing those parts. The benefits of additive manufacturing include faster time to market, increased customization, to name a few. And even though the cost of producing an individual part might be more expensive sometimes than traditional manufacturing, that's offset with the ability to get the part to where it's needed as quickly as possible and not having to build and store inventory that could meet every demand for every replacement part required, which we know is impossible. Additionally, an added benefit of additive manufacturing is it's friendly to the environment. The powder can be recycled, there's less transportation and warehousing costs, and a smaller carbon footprint. So you ask, what are the barriers to full industrialization? Well, it's ironic that the same factors that are driving growth and adoption are also causing quality issues. That's where Sigma's technology comes into play. PrintRite 3D has been proven to identify and classify defects and during the build process to ensure that the part's quality is consistent, regardless of where the manufactured along the supply chain or on what printer and within what process. It's the only technology that we know of that can make this claim. And for us, adding a new printer from a manufacturer takes a matter of weeks. As a matter of fact, our vision from the very beginning as a small engineering team was always to build an agnostic third-party solution that went across printer types. Our problem was we only had one printer. So not only did our engineering team develop and produce in 18 months a product, they used our customers' printers to do R&D as they were developing the technology. Truly a remarkable feat. This is what that production manager might see from home as he manages those factories remotely. In this particular case, he set the tolerances for a particular part. You can see as the printing process gets to layer 250, the tolerances become closer and closer to his limit. The production manager in this particular case can make the decision whether to continue the production of that part or stop it and correct the process. The other day, I was asking an engineer to tell me what they heard from our user when he first sees his part being built layer by layer using our product. This particular engineer was communicating with a new Japanese user who's evaluating our technology, and the conversation was through an interpreter. He could hear the question in Japanese, and he could hear the engineer saying, "Sugoi, sugoi." He asked the interpreter, what is he saying? He was saying, "Amazing, amazing." It took a while for that to sink in. I mentioned the term radical collaboration earlier. Well, my definition of radical collaboration is not only to work in collaboration with our customers to our mutual benefit, but also to advance the additive manufacturing industry as a whole. Therefore, our roadmap includes a knowledge base that we will be building over time based on printer type, number of lasers, powder, design type, and we'll be sharing that with the industry for continuously improving and driving efficiency into the printing process. Now, our technology lead is significant. However, as you know, technology alone doesn't always win the day. We're equally proud of and aggressive with our go-to-market strategy, as well as our continued initiatives with international standards groups such as NIST, ISO, and ATSM. We've also been very careful to protect our IP with a comprehensive patent strategy. The latest 2 patents were granted just last quarter. Now you might ask, how can you and how do we measure our progress? How do we make sure we're on the path to becoming that de facto standard? Well, it's by filling in the steps that you see in front of you. We can measure our progress as we fill in that chart. The end result will be more large companies like Airbus and Baker Hughes and Oerlikon going in to evaluate our technology. More major universities and research and development organizations who are training tomorrow's manufacturing leaders on our technology. Continued collaboration with the standards groups. Closer associations with software companies like Materialize and Ansys. All this resulting in OEM contracts with both hardware and software companies providing printers and additive manufacturing software to the industry. The end result will also be large companies going into serial production with multiple printers in multiple factories around the world. All moving us towards accomplishing our mission of becoming the industry's de facto standard. We've also built a business model that's designed to produce repeatable and dependable revenue streams with increasing profitability. You will see our mix of revenue change over the years from end user and R&D organizations, where our cost of goods are relatively high, to mostly OEM revenue, where we ship software only that has a gross margin of greater than 90%. So that's our story. I hope that you found it interesting, that you finished your cocktail and the dinner bell just went off. Before you answer that bell, I'll be glad to answer any questions that you might have. Thanks for listening. All right, so I have a couple of questions coming in here. Let me just refresh the screen. One of the questions is, what is the impact of COVID-19 on our customer base? I think there's a short-term and a long-term impact, and it depends on which industry we're talking about. The short-term impact of COVID-19 on us, like all companies, is that most companies are reevaluating their P&L and their expenses, and they're temporarily putting almost everything on hold until they have a clearer picture of when we're going to come out of this and how it affects their business. We're clearly being affected just like everybody else is from that phenomena. When it comes to the longer-term impact on our business, as you might surmise from the way I started the conversation, we expect that it to have very little long-term impact on our business. We see no slowdown in the conversations that we're having with people or with the people that are testing our software. We do see a slowdown when it gets to the procurement process of getting a purchase order through, but we believe that'll be temporary. Okay, let me see the next one here. Do you plan to have the technology working on plastics or other materials? The answer is no. Our expertise is in the metal side. You'll see us deal with other ways of monitoring the quality in metal printers, but we don't have any plans to go to plastic or monitor the quality of a plastic printer. Here's another question. What might we next expect relative to your progress going up those steps that you showed us? For us, the next thing that you should expect to see is an OEM deal with a hardware manufacturer, a continued reseller agreement and joint selling agreement with software manufacturers, and we should see a couple of our end users go into serial production with multiple different printers from different manufacturers. And let's see, I'm going to refresh this one more time here. You had mentioned before increasing revenue quarter over quarter. Is that still the case? The answer is yes. I believe that you'll see increasing revenue quarter over quarter. You'll see our expenses relatively flat. They might even go down a bit. One of the things that we're benefiting from is technology ourselves. In the past, where we used to put an engineer on a plane to go do an installation, we're now experimenting with headsets that have augmented reality that we ship to our customer, and they actually become our eyes and our hands, and our engineer walks them through the installation remotely. Of course, there are two things that result from that. The first is that we get a much more competent customer, and the second is that we become much more efficient ourselves in using the money and lowering our expenses. Well, that's it. I hope that I've answered some of your questions. I think we've just about run out of time. I'd be glad to answer more. If you have them, you can email them to the contact that you saw at the end of the presentation. If it wasn't there, it's MZ, and we'll be glad to answer those questions as they come in. Thanks again for your time, and enjoy your dinner.
This concludes today's webcast. You may disconnect your lines at this time, and thank you for your participation.